All right, so here we are, one of our last couple of videos of the year. Today we're going to be talking about surface area. So last time we talked about what volume was the amount of space enclosed within the object. Today we're going to change gears and talk about surface area. So take a minute and jot this down, but surface area is the amount of area around the outside of an object. All right, so it's like, think about wrapping paper to cover a shape. All right, it's the amount of space around the outside of a 3D object. And the difference here is they're not going to give you formulas for surface area. All right, the volume formulas they give you, because those are kind of unique, different formulas. The surface area formulas are just going to be made up of all the two-dimensional area formulas that we already know. All right, so I'm going to move on. If you need to pause and finish that, go ahead. But here are the formulas that we need for today. We already know all of them. Rectangle, circle, triangle, trapezoid in some cases. So as I've been saying, you need to have these formulas memorized. So let's skip down to 13.3. Surface area of three-dimensional figures. Okay, now it's up to you to kind of think your way through these. There's not a formula I can give you, like I said. But to find the surface area of a prism, we just need to think really carefully. All we're doing is kind of unwrapping. We talk about this net. We're just unwrapping this six-sided figure, right? 1, 2, 3, 4, and then we have the front and the back, 5, 6. We're unwrapping it and just turning it into 6 rectangles or squares or circles or whatever the case may be. And it's our job to find the area of each one of these shapes. So in this case, they're all rectangles. We just need to find the area of these 6 rectangles. All right, so when you're ready there, you can scroll down, pause if you need to. The key for surface area, let me scroll up here for a second. The surface area, since it's all just the two-dimensional area formulas combined, it's the 2D area formulas combined, the surface area will always be in units squared. So volume is cubed. Surface area is actually just going to be squared. So let's try one. All right, rectangular prism. So it's the same drawing from before. So if it helps you, you can actually think about what we did before is unraveling or unfolding this whole diagram. And I think our drawing from our net above, we'll make it look the same, looked kind of like this. 1, 2, 3, 4, 5, 6. So if it helps you to think of it that way, that makes it a little more confusing for me personally, but if that helps you, that's great. Here's what I'm going to think about. Looking at this picture, I know that this is a rectangle, this base. So if this side's 2, means that side right there also has to be 2 centimeters. If the front edge of our rectangle is 3, means this edge has to be 3. But the thing we know, since these bases are the same, we have a 3 here, we have a 3 here. We have a 2 here, we have a 2 here. My 6, the height is 6, that means all the heights of all these rectangles are all 6 centimeters everywhere. Okay, now I'm going to be able to do something a little different that you may not be able to do on your paper, but I'm going to color these in one at a time. So I'm going to do the area of these 2 bases first. Remember, all it is are these two-dimensional shapes. So what I have at the top and bottom, those 2 purple rectangles I just highlighted, are 2 congruent rectangles, and the area of those 2 rectangles are just base times height, or length times width, which is 3 times 2. So that covers the top in the bottom. So it's 3 times 2, which is 6. But remember, there's 2 of them, so we're just going to double it. So I'll just do 6 times 2, which is 12 centimeters squared. And that covers, like I said, the top and the bottom of our prism. 12 centimeters squared. Okay. Now what I'm going to do with my purple again. Now I'm going to highlight the front and the back. So we see this front purple rectangle right there. So this front purple rectangle, it's actually the same exact dimensions as the one in the back edge. And the reason why I labeled all this, now we can see pretty clearly, this front purple rectangle has a base of 3. So I'll draw it over to the side if this will help you. It has a base of 3 centimeters and a height of 6. So I can take those dimensions, and the front and the back rectangles are 3 times 6, which is 18 centimeters. But there's 2 of them, so we double it. So we have 18 times 2, which is 36 centimeters squared. All right, you guys with me? And all we have left at this point, we did the top and the bottom. We did the front and the back. We'll get a highlighter out here. This might help you see it better. Now all we have to do is the left and the right. So there's the left-hand rectangle right there. There's the right-hand rectangle. So if you have colored pencils or highlighters, this might help you to see. So those 2 rectangles, the left and the right-hand side, looking really carefully at the dimensions, it has a width of 2, and as always, the height is 6. So my last pair of rectangles, I know the area is base times height, or width, length times width, whatever, which in this case is 2 times 6, which is 12. So that's the area of this rectangle. But remember, there's 2 of them. There's the matching rectangle on the opposite side, so we take that value and we double it. And that will give us the surface area, or the wrapping paper, for this one. 12 times 2, which is 24 centimeters squared. And now to find the total surface area, we just take those 3 values, we add them all up, and we get 12 plus 36 is 48, 58, 68, 72 centimeters squared for our final answer. So it's just a matter of you thinking really carefully through all your formulas and adding them all up. All right, cylinder is a little more difficult. So for the cylinder, go ahead and pause and jot this down. So I'll wait for you to pause it. All right, so hopefully you have that written down and thinking carefully. Remember, for the surface area, we have 2 bases. They're both circles. We hopefully should have memorized by this point that the area of a circle is pi r squared. So we have 2 of them, so we just do 2 pi r squared. That's the area of this circle and this circle. Now, the lateral area, we talked about this in class. That's a new word probably, but the lateral area is the curved area, everything that's not the bases. So the lateral area is kind of everything here. Now, I took someone's water bottle in class, and remember how I cut that slit down the side of it and unrolled it like the label of a soup can? What we all came up with was that this label, the lateral area, once you unroll it, the height just matches the height of the cylinder. But if we unroll this label, the width of this rectangle actually becomes the circumference of the circle, which is 2 pi r. So the rest of our formula, besides the 2 circles, besides the 2 pi r squared, now we have the circumference of the circle, which is 2 pi r, times the height of the cylinder. So there's a big formula there, but we have to take the 2 pi r squared and add it to the 2 pi r h, which is the rectangle. So, cylinder, we have a radius of 2 and a height of 8. The surface area, I'll write that as surface area, equals. We know we have 2 circles. So I'm going to go a little quicker here. Pause if you need to. We have 2 circles We know the area of a circle is pi r squared, but we have 2 of them, so we do 2 pi r squared. Plugging in the r for the radius is 2, so 2 squared is 4. So we have 2 times 4 pi. So the area of the 2 circles are 8 pi. Now we're going to think about cutting this lateral area and unrolling it. So the lateral area is the circumference of the circle, 2 pi r, times the height of the cylinder, which is 8. So plugging in what we know, we have 2 pi. The radius is also 2, so I'll put times 2 there, times the height. 2 times pi times 2, which is 4 pi, times 8 is 32 pi. That's the lateral area. And the whole surface area, we add them together, 8 pi plus 32 pi equals 40 pi. And obviously we could put that into centimeters by putting it into our calculator. But the key here is, if I think about unwrapping the label of this can, we turn it into a rectangle with a height of 8 and a width, which is the circumference of the circle, which is 2 pi times the radius. And that's how I got this part of my formula right there. So these formulas are a little more difficult. We'll do the next page in class together. We'll do our pyramid and sphere. But hopefully that went all right. Review the video if you need to. We'll practice this in class together for sure next time. And I'll see you in class.